Good morning students. Today we are going to discuss about managing the system. First of all, what is meant by maintenance? When we will see the maintenance? So whether the maintenance will be happen during the development or else after the delivery of the product. So most of the cases, as we know, the maintenance means when we deliver the product, when some faults are occurred or identified by the customer, to rectify those faults or to fix the correction of those faults, maintenance is required. So we can say maintenance will be happen after delivery of the product. So meaning that when the users are using the product, the maintenance will be coming to the picture. So maintenance will be coming to the picture over a period of time when the product is used by the users. So that is a maintenance when we use. Now as we know, the hardware maintenance and software maintenance, whether these both are similar. If you think when you buy a AC machine, whenever after usage of the 2 months or 3 months or 1 year, you may get you identify some of the faults. You're not getting AC properly, or the cooling is not happening properly. So you call maintenance people, and they will identify by which cause of the parts it's cooling less, or what the parts need to be replaced. So they are going to identify and they replace the faults, and they make the fault corrections. So as the same way we can do in the software? No. So whenever you're getting the maintenance for with respect to hardwares, when you use a hardware component for 2 years or 3 years, you will need the maintenance. If you have a bike, after riding of 500 kilometers or 1 year, you need the maintenance. So just like whenever you're using the hardware components over a period of time, it is requiring the maintenance. But whenever we are having in the software, for example, you are having the for loop. If you run that for loop for 100 years or for 100 times, or for 1 day, or to 1 lakh of days, nothing will be happen. It will not damage, or it will not decrease the performance of the system. So just meaning that whenever we are having the for loop usage for more number of times, it is not degrading the performance of that program. Okay, so here what is mean by software maintenance? So we know that hardware maintenance means over a period of time, whenever you are using the continuously some hardware, some parts are degrade the product whole overall performance. So for that, to improve the performance, the parts which are causing the degrading of the performance of that product, we need to be replace it. But what is happening with respect to the maintenance of the software? So in the case of software maintenance, it's depends on the user and environment, and the world changes, meaning that whenever the software is delivered to the user community, so later on after users of that software, user come to know that user is expected some of the things need to be added to the software, or some modification of the function need to be done. So that is the way for that purpose we require the maintenance in the software. So it's not only based on depends on the user requirements. Sometimes the nature of the business may change. For example, if you're having the tax calculation, at present we are having the GST and the CGST, SGST is there. It is introduced by the central government newly in the last 2 years back. So before the 2 years, we are not having the calculation of the CGST and the GST. So it is not the user requirement. The nature of the tax calculation was changed. So that need to be incorporated into the software. So for that we require the maintenance. So here the maintenance is not only depends on the user requirement, satisfying the user. The software evaluation, the software maintenance maybe depends on the nature of the system also. Nature of the system changes. So how the business changing, based on that also we require the change of the software system. Okay, in other terminology, the maintenance is also called as evaluation of the system. So why we are calling the evaluation? what will be happening in the evaluation? In the evaluation, you may add some functionalities, you may remove some of the functionalities, or else you can modify the existing functionalities. So you're doing something and you're releasing the new product. Okay, so here in the maintenance also, we are doing what we are doing. We are fixing the faults, and based on the user feedback, you're making the fixation of the corrections, and you're adding this functionalities. So here there is an similarity of words of maintenance is nothing but evaluation of the system. Okay, so we can also call as a maintenance is nothing but an evaluation of a system. Now in today's topic, we are going to discuss the main objectives of the software maintenance: system evaluation, legacy systems, impact analysis, software reservation. So the main objective of this is how the software is changing, what are the parameters are going to be involved in the evaluation of the system. These things we are going to learn in today's lecture. As we discussed, maintenance, any work done to change the system after it is in operation. So as we discussed, maintenance, any work done to change the system after it is in operation. So when we are using the software, then we face some of the faults, and we as a user using that system will give the feedback what are the extensions or modifications we require in the system, that will be intimated to the developer. So the developer, as per the user's requirement or the nature of the system changes or business changes, he will do the corrections in the existing system. So software does not degrade or require periodic maintenance. So as we said, the vehicles, whenever you are using the hardware components or automobile vehicles, whenever you are using for 1 year or 2 years, continuously we require on periodic basis maintenance. For example, if you use AC machine or geyser, we require the maintenance for those for at least minimum for 1 year. If you are having the vehicle per 1 year, at least we need to go for one-time maintenance in a year. So that is the way we not required periodic maintenance for the software. However, a software is a continually evolving. So the software is a continually evolving process. So we all know. So today's software is continuously evolving. Whatever the software or whatever the application we develop today, the needs of that application is changing tomorrow. Okay, so we need to incorporate some of the changes, some of the enhancements, and need to be done in the existing software application. So software systems may change not just because a customer makes a decision to do something a different way, but also because the nature of the system itself changes. So as we discussed, it's not only depends on the user's requirement, the evaluation of the system is taking place. We taken an example of tax calculation. So now the central government has introduced CGST and SGST for the business people to calculate their tax, how much tax they need to pay. So now earlier in the tax calculation, we are not having the SGST and CGST, central tax and state tax. So now we are having this GST introduction in the tax calculation. So the nature of the business was changed. The new laws are incorporated by the government. So we need to be incorporated. This is not the user requirement. This is the nature of the law of that business was changed. So the change may not only depends on the customer requirements or user requirements, user satisfaction. It may sometimes depends on the nature of the business change. Now in this slide we are going to learn about Lehman system types. So Lehman has derived some of the principles based on his observations, in what way the systems has made changes or having an impact of the changes. Based on that, he classified into 3 types of the systems. So first one is a S system. So S system formally defined derivable from a specification. example matrix manipulation. So meaning that in the S type of systems, we well understood the specifications and we well understood the solutions. For better understanding, for example, if I given a problem to write a C program to, or write in a program to implement the bubble sorting. So as you know, the problem is very clear. You need to write the bubble sorting, and you have also known the solution. What is the logic for the bubble sort? So similarly, when I ask you to do a program or write a program for arithmetic calculations, so to calculate addition, subtraction, division, these are the fundamental one. So already you know the solution, how to implement it, and what the result you will get, so that will be known. So similarly for the matrix manipulation, or that means matrix operations, to matrix additions, transpose, to matrix subtraction, to matrix multiplication. So already you are familiar with the solution. So you are well known about the solution, and you are well known about the problem. So when you well understand about the specifications of the problem, and when you well understand about the solution, those kinds of the system is called as a S type of systems. So these S type of systems are less prone for the changes. So whenever it is changed, means the problem is a completely a new problem. Okay, so why? Because you're completely understood, you're having no uncertainty in the specifications, and you're not having any uncertainty in the solutions, and the solutions are also feasible to implement. So there is a less chance for the changing in the S type of systems. So the systems which are causes less chance or no changes in the system evolution, those kind of systems are called as S type of systems. Next category is the P systems. Requirements based on the approximate solution to a problem, but real world remains stable. The P systems means you well understood about the specifications, you well understand about the solution, but the solution is not feasible, or you are not able to completely implement the solution. For example, if you take a chess or gaming any application, for easy understanding we'll take a chess example. So in the chess, theoretically to write the solution for each step, it's a very easy, but whenever it is need to implement all the different ways of the solutions to play the chess, that is a interactive session, interactive playing with the system. So in that aspect we need to be having all the combinatorial classes. So it is a permutations and combinations, like we have a large complexity of the solution, and sometimes you may miss some of the solutions. Whenever it is coming to the playing of that one, playing the chess game in further time, over a period of time, you come to know that one some of the solutions you have missed. So you are going to add that additional functionality which you have not added in the existing system. So this will move on to implement the system completely in the future. For every iteration you are going to add some of the missing steps which are not there in the existing systems in the earlier iterations. So the P systems is in another words we can call it as a incremental changes. So the systems which are affected towards the incremental changes, the systems which required incremental changes, those systems are called as P systems. So the P systems are well understood about the problem and well understood about the solutions, but you are unable to implement, or it is infeasible to implement the solution. So in the you're not implementing all the solutions at once in the system. That will be happen over a period of time. That will also you have to be you will be identified the solution, some of the things are missed in the when the product is used by the user community. Then they will give some feedback. Based on that you made some changes in the next iteration. So the P systems are nothing but incremental changes. Example is chess programs. So next one is E systems. In the E systems, M is called embedded systems, embedded in the real world and changes as the world does. Software to predict how economy functions, but economy is not completely understood. So what is this E systems? So E system means you are aware of the you are not in the S systems and P systems, you are well understood about the specifications, and in the S systems you are well understood about the solution. In the P system also you are well understood about the solution, but that solution is infeasible to implement. That you are implementing the solution in the incremental manner. So that is the P systems. When it comes to the E systems, you are unaware of the specifications. You are not well understand about the specifications. There is some uncertainty is there in the specifications. So automatically, whenever there is an uncertainty in the specifications, when it is coming to the next iteration, you have to change the system life cycle. So the system need to be face changes. So you need to make the changes in the E system. So the E system is more prone to the changes. E system is a continuously evolving changes. So the system which are faced to or occurs or need continuous changes, those kind of systems are called as E systems. For an example, if you take software, the economy prediction. For example, if you take our stock market, when to buy, which one need to be, or else we'll take a better example of banking applications. So in the banking applications, for every 6 months the interest rates will be changed. So according to that, you need to be modify our code. So our system need to be changed. So for example, for easy understanding, you can have the bank of fixed deposit interest rates. So they are going to be changed for every 2 months or 3 months. So frequently the central government is announced about the reverse repo rate and repo rate, and the banks are going to be change the fixed deposit rates. So according to that, a system need to be do some modifications. So according to that, the software needs some modifications. So here the specifications are not clear at the initial step itself. So whenever the specifications are not clear, in the next iterations, some of the specifications may be clear, and according to the specifications we are going to do the modifications and we are going to release the new product. So these kind of systems are called as E systems. E systems are towards continuous affecting changes. Thank you. Now these are the pictorial representation of the type of systems. S system. Problem solved is related to the real world. So if you observe here, if the world changes, the result is completely a new problem. Okay, so you know about the real world. That means that the problems are there in the real world. Whatever the problem has been, we found, we well understood about the problem, and we well defined about the requirement specification. We well understand about the specification, and you are implemented the system. Whatever the result we take as an output from this system, that will be related to this problem only. Okay, so there is no difference of problem and the solution. There is no conflict between the problem and the solution. So because you well know about the problem, and you will know about the solution, how to implement. Before after the specifications are mentioned, you well known about the solution. Before the implementation, you well know about how to get the solution for this one. What is the solution for this given problem? That is a well known prior, right? So here this arrow is subject to change, comparison and subject to change. So here the comparison is in this type of systems, the real world only changing. So whenever we are talking about the real world changing, means completely it is a new problem. Okay, so as per the S systems, we said when we completely understood the problem, we are defining well understood about the specifications, and we well known about the solution. Okay, so here whenever we are saying the real world is changing, meaning that we are having the new problem. Okay, so that new problem is also a well known problem. Okay, so for that well known problem also, we are having the well known requirement specification and well known solution. Okay, so here whenever it is having the real world changes, means it's a completely a new problem. Okay, not the existing problem. Okay, in P-type systems, the solution produces information that is compared with the problem. Okay, so if you see this flow chart of P-type systems. It is a real world, problem, abstraction, requirement specification, system, information. So here if you observe this one, real world, abstraction, requirement, system, information, these are changing and the problem is not changing. Okay, so because the problem is well understood, the solution is also well known, but we are unable to implement the solution completely in one step itself. Okay, so here it's infeasible to implement the solution. So in this case, what is happening here, so whatever the problem it was given, based on our understanding, we are going to define some of the abstraction. We are not completely defining the full solution here. Okay, so some part of the solution you are defining for the given problem, and for that abstraction you are specifying the requirements, and whatever the requirements you have specified, according to that you are implementing the system, and the resulting solution you are comparing with the problem. Okay, so this is the comparing line. Okay, so you are comparing that solution with the problem. So whenever you find some of the solution, just like whenever you are playing the chess, for the some steps you are not finding some solution, the computer whenever you are playing the interactive play with the system, when you play some of the steps, according to that steps the system is not having any further movements. So in that sense, if that was identified, then according to that the abstraction will be changed and the requirements will be changed, and later on the system is also going to be changed. Okay, so here the problem is not changing. We well understood about the problem, but what is happening here, the solution is not completely implemented. Okay, because all the solution is not known in one step itself. Whenever it is using by the user community in the next iterations, by taking the feedbacks, we will come to know that one, what are the missing things are there, what are the additional things need to be added. So that will be known in the next iterations. So here this is the way we are having the flowchart. So if you understand this second point, the system resulting from changes cannot be considering a new solution to a new problem. Rather, it is a modification of the old solution to find a better fit to the existing problem. Okay, so you can better understand with this statement. So when it is in the S systems, whenever you are comparing that solution with the real world, so it is a completely a new problem. Okay, there is no conflict between the problem and the solution. But here, whenever you are comparing the solution with the problem is not satisfied with the given solution. Okay, so because we given some abstraction of the problem. Okay, we are not completely implemented this problem. We taken some of the abstraction of the problem. Whatever the missing things are there, we are going to incorporate again those missing things in the abstraction. According to that, we will change the requirement specifications. Okay, so here whenever we are doing these iterations, we are not generating a new solution, new problem. Okay, so we are making some of the enhancements to the existing problem only. Okay, but whenever it is in the S systems, it is a completely a new problem. Okay, the system resulting from changes cannot be considering a new solution to a new problem. Okay, so whenever you are making in the P systems changes to the system, it is a meaning that it's not a completely a new problem. We are doing our better, and you are doing some of the enhancements to the existing system. But in the case of S system, you are making a new problem, new solution for the new problem, but you are not making the enhancement, or you are not making a new problem for the existing one. It's a completely a new problem in the S type system, but in the P system you are enhancing the existing system. Okay, now if you observe this E type system flowchart, the changeability depends on its real world context. Okay, so what is happening here, total real world is changing. If you see this dashed line. Okay, so in the S type and P systems, the problem is not changing. Okay, why? Because we well understand the problem, and the problem is fixed. Only the specifications are changing, and the solution in the incremental fashion, it is changing in the P system. In the S system, little amount of change in the specifications, and no changes, maybe no changes will also be allowed in the S type of systems. But in the case of E systems, the business environment is changing. According to that, the problem definition is changing. According to that, the developer abstraction definition is going to be changed. Requirement specifications are also going to be changed. System implementation will be changed, and the solution will also be change. Okay, so every phase is going to be a change in the case of E-systems. If you see in this flow chart, this dashed line is indicating the change of that particular phase. Okay, so if you observe, problem changing, abstraction changing, requirement specification changing, system changing, and the solution will also change. Okay, so because of all this changing, due to the real world is changing. Okay, just as I said, whenever you're making the fixed bank applications, the interest rates will be changed, or else for easy understanding, you can take a KYC. Now we are having the KYC, know your customer, that need to be incorporated in every bank application and mutual fund applications. So that is the new law is incorporated by the central government, so that need to be incorporated in the application. So that is not the user requirement or customer requirement. This is the law was changed, the business was, the nature of the business changed. So according to that, we need to change the problem definition, abstraction need to be changed, requirement specification will be changed, system design will be changed, and implementation will be changed, and solution will also be changed. Okay, so this is the way we are having the change impact for all the phases in the E type of systems. Now if you see S type of systems unchanged. Okay, so it's not meaning that it will not completely unchanged. It will be allowed less amount, ignorable amount of changes are allowed in the S type of systems. So P type of systems, incremental change, just as we seen in the process models, incremental model and iterative model, evolutionary model approach or phase development model approach. In that same an approximate solution will give in the first phase. In the next iteration, we are going to give the next some more additional solution will be added to the existing solution. So changes as discrepancies and omissions are identified. Okay, so E type of systems, constant change. Okay, so it is completely affected the continuous changes in the system. Okay, it's not having some time for the changing of the system. It's completely interacting with the environment, and business nature will be changed. So according to that, we need to change our system. Okay, the system is having an impact of continuously changing. Remaining topics we'll discuss in the next lecture.